our website and social media too. As a parent myself, I know how difficult and challenging the last few months have been. The school holidays were very welcome, but probably not much like previous year's holidays for most of us. So we thought these sessions would be a good way to move us all back gently into learning before getting back to school. I really hope you and your children enjoy them. Now, before I hand over, I'll just go over the housekeeping for today. Everyone will be muted and all cameras will be switched off, so you'll only see and hear from the presenter throughout most of the session. If you have a question, please use the chat function. If it's not possible to answer during the session, we'll try and get back to you afterwards. I'm sure you'll all be respectful, but remember that many children are joining their parents in this, so please consider before posting any comments. Also, please remember to use the hashtag MPFS back to school and share pictures of yourself and your children taking part either live or following a recording. We'd really love to see them. So I hope you all enjoy yourselves. Thanks and bye for now.
Hello there, everyone. Hopefully you can all see me. Okay, so hello there, everyone. My name is Craig and I'm from Dynamic Earth. Fantastic to have you all here with us today, whether you're joining us live or you're joining us afterwards on the YouTube recording. So as you heard from Joanne at the National Parenting Forum of Scotland there, the session here will just be me for the next 45 minutes or so. But I'll be happy to take your questions afterwards. If you pop them into the chat function at the bottom, I'll be happy to read some of your questions afterwards and get back to you with as many as I can in the time that we've got there. Any that I can't answer in that time, I will come back to perhaps afterwards. I can send an email to the National Parenting Forum of Scotland and perhaps they can send out the questions or we'll put them in the YouTube comments. Okay. So I'm Craig, I'm from Dynamic Earth in Edinburgh, and today I want to talk to you today and do some activities with you today. Whether you're a parent joining us on your own or you're a parent with your learner who might be heading back to school very soon, whether that's in primary school or perhaps even heading up into high school, or perhaps you're in early high school already, secondary school, and you want to join us for some of these STEM skills, but also exploring the area of creativity as well and links between STEM and creativity. I've got a bit of a PowerPoint to share with you as well. I'm going to be flicking between my camera view like this and also the PowerPoint presentation as well. And in some of the cases, it might actually be useful to head back to the recording on YouTube if you want to have a little go at some of the activities that I'm sharing with you, just in case I don't give you quite enough time to explore them all today. Okay, so we should probably get started and have a little look at what it is we want to do today. So let me just share my screen with you all. Okay. So just in case you haven't been before, this is a picture of Dynamic Earth here. And behind there is the Salisbury Crags that we're going to explore a little bit later on together, okay? But first of all, let me just show you what it is I want to achieve today. So our objective for today, I want to explore creativity and STEM. STEM, of course, being science, technology, engineering, and maths that we love to explore here at Dynamic Earth, along with creativity. We want to practice some of our STEM skills, and perhaps along the way, we'll learn some science as well. So at the end of this session, we'll come back to these three objectives and we'll see if we have met them at least a little bit. There are a huge number, of course, of STEM skills that you would use in both schools and also if you were going to be on to be a scientist or an engineer or a mathematician. But we can't explore them all today, but we can have a little look at some of them. But to get us started, what I would like to do is a little bit of a creative STEM, a little creative sort of warm up. So you might want to grab a pencil, you might want to grab a bit of scrap paper there as well to help you out with this one. So I'm going to give you just a little second to do that. You want to grab some paper or anything. You can also just do this in your head. You can just do it in your head as well. So don't worry about it too much, just a little bit of a warm up. Okay, now the challenge is to get us all started. I want you to complete this squiggle. Might not make much sense, but this squiggle here, you can copy the squiggle down. I'm going to do exactly that. So copy this squiggle down just now if you're using a bit of paper, just roughly. It doesn't have to be exact. And what I want you to do is turn this nonsense squiggle like I've got here, just copied from the screen. Turn this nonsense squiggle into a picture the best you can. You know, you're only going to have 30 seconds to do that. You can do it in your head as well. Try and make an image out of it. If you want, you only have 30 seconds. You have to draw and think fast, but it's a little bit of a warm up for our brain. Okay, so will I get started? I think I'm going to click on the timer, give you 30 seconds to give that a try. Turn this squiggle into a picture. Okay, 3, 2, 1. Okay, so started your 30-second timer now. And this will all make sense afterwards. I'll make sense of all this. Now, let me have a little go at this then. Oh, not done this for a little while. That's not looking very good. Yeah, just give it a go. Okay, it's 2, 1, and the time is up. Oh, I didn't even finish mine. Okay, so you might not have finished yours either, and that's okay. You can come back and give it another go afterwards. But let me just show you what I've come up with. So I just quickly turned that squiggle into a bit of an unfinished rabbit face there. So you might be able to see up in my video there, not very big picture, I know, but you can see there. Sadly, I can't see all the amazing things that you've probably come up with, but I've got a couple of examples for you here. So we've got an elephant there, we've got a bit of a crocodile. It looks like perhaps the crocodile one in particular, perhaps it's longer than 30 seconds. Sorry for that. But I bet some of you drew some animals as well. Actually, I didn't even think of that. When I drew an animal, I didn't even think of the connection here. But an animal is quite a common one to draw because it often comes into our mind very, very quickly. Now, as I say, I can't see all the things you've done, but perhaps you can send us your pictures if you like. Using Twitter might be one of the best places to do it. You can tag us at Our Dynamic Earth afterwards if you want to do that. So what was the point in all this then? Well, this is to get our creativity going. But we have to think about what creativity actually is to make sense of this, okay? So you might not consider yourself particularly creative, and you might not think your picture is particularly good, but let's see if you identify with any of these things. So creativity skills that you were practicing there, believe it or not, there are curiosity. You probably wondered what on earth I was talking about, getting you to finish a squiggle drawing. You had open-mindedness, because I hope that lots of you went into this just thinking, I don't know what he's talking about yet, but I'm going to do it. I'll just get on with it there. Imagination, of course, you were stretching your imagination to turn this squiggle into a picture. And your problem solving as well. You were looking at these lines that were already drawn, the squiggle that was already there, and thinking, how can I complete this and make it something else? So you were following these 4 things: curiosity, open-mindedness, imagination, and problem solving. And this is how in Scottish education, we view creativity and the skills associated with creativity. Now, you might also agree with me that all of these 4 things there sound pretty much like a scientist, or perhaps a technologist, or an engineering or a mathematician as well. They're always following these 4 things as well. So when you're practicing your creativity skills, you're also practicing your STEM skills. They're all interlinked, okay? So really, really important for us to sort of think about that as we go on through the next little bit of my presentation and the activities I'm going to do with you. Think about curiosity, open-mindedness, imagination, and problem solving. And when you're doing your science homework or your geography homework, or you're at school doing these things, think of these 4 things as well. These are what get your brain going, your brain into a science mode, into a STEM mode, and also in creativity mode as well. So science relies on creativity, and it is creative. And creativity also is practicing lots of other STEM skills as well. So here at Dynamic Earth, we explore the story of planet Earth, okay? And we look at how the world works and how it operates. And there's nothing more creative, surely. If you were an Earth scientist studying planet Earth, from the environment to the rocks below our feet, and understanding the mountains or the fish in the sea, anything like that, there's surely nothing more creative than thinking up experiments and thinking up ways of analyzing the world around us and understanding it and processing the results that you see and you get and making sense of it all. So that's what we're going to have to take a little look at today. So one thing that we're really, really passionate about here at Dynamic Earth is the climate emergency, the climate crisis you might have heard of. I'm sure many of you watching today have heard of climate change. And we talk about it lots in Dynamic Earth, and we think about how we can share climate science with everyone back at home and everyone that comes to visit us when that's a possible thing to do. So you might have heard of climate change. I'm sure you're aware of that. And you might have heard that carbon dioxide, CO2 in the atmosphere is one of the causes for that. So it's extra carbon dioxide or carbon going into the atmosphere that's causing global warming. It's causing changes to our weather patterns, and it's causing more severe storms, for example. But what you might not be so aware of is the link between the atmosphere and weather and climate and the oceans. Now, the oceans cover 70% of our planets. They're really, really vital, and they control our climate and our weather, and also the other way around as well. Our climate, our atmosphere, the air around us also can influence the ocean as well. So what I want to do is do a little experiment with you all to demonstrate how that happens. And as we're doing that, remember to stay open-minded. Use your curiosity to lead you into the experiment, your problem-solving skills to work out what's going to happen perhaps, and your imagination just to get you into the realm of a climate scientist or an ocean scientist, as we're going to be today. Okay, so I'm going to tilt my camera down to show you this little bit of an experiment just now, okay? So let me just tilt my camera down here, and what I've got is a little bit of a setup for you here. I'm going to just swap my glasses over for some safety goggles actually. Okay, so what I've got is a big beaker, and inside there's a little beaker just suspended above there. So we're going to set this experiment up as if it's the ocean and the air. So into the big beaker, I'm going to pour in some water. Okay. Now this here is our ocean, right? Doesn't look much like it, does it? But I can actually add something to that to help out, and it's actually this thing here. This is a chemical, which is why I've got the safety goggles on. This is a chemical here called bromothionyl blue. Now, bromothionyl blue will not only make the ocean a nice blue ocean color, hopefully for us, but also it's a special chemical. We'll squeeze some in there. It's a special chemical called an indicator. Now, a chemical indicator can show us how the chemistry has changed. And in this case, you can see the lovely blue color there. In this case, we're going to be able to see how the acidity of our ocean here has changed. This will all make sense afterwards, okay? So we'll have a little look. We've got a nice lovely blue ocean there. Okay, pull this back a bit for you. Put my bromothionyl blue to the side there. Okay, so a little bit of chemistry here. Let's see if we can change the chemistry of the ocean and why that would happen. Now in the top one here, I'm going to add some basic sort of things you might have in your kitchen. These are chemicals that you'll probably have them in your kitchen, and it might even be something you've done before, and that is adding bicarbonate of soda and vinegar together. Now if you've ever done this before, you'll know that it bubbles and froths, okay? And that's because of all that carbon dioxide being created. That same stuff that's released from our factories, our cars, our manufacturing around the globe. We've been doing it for hundreds of years, especially here in the UK. So that carbon dioxide goes into the atmosphere, just like our carbon dioxide here is going to come from the small beaker, from the bicarbonate vinegar, into the larger beaker. And we'll see how that does to our water or our ocean down below. Okay, so maybe 3 scoops for good measure, eh? So I've got my bicarbonate vinegar there. I've also got, I'm going to add my vinegar in there, and I'm going to put this lid on, to keep it nice and tight over the top. So this is going to froth up, but hopefully it's not going to froth over the top. Okay, so it's not the vinegar that's going in here. Hopefully with the carbon dioxide, it's going to fill up this big beaker. Okay, so let me pour in some vinegar, and then I'm going to put the lid on there. Okay, so you will not see anything immediately happening, but right now there's lots of invisible carbon dioxide gas coming out of this small beaker at the top, and it's going to be floating around into this bigger beaker here right above the ocean. And we're going to study how that changes the chemistry of the ocean. But that's going to take a minute or two to do that. So what I want to do is explore some other STEM skills relating to doing a science experiment such as this. Okay, so let's just put that to the side there. And I'm going to bring the camera back up here. Hope you like my safety specs. So what I want to do is just share my screen with you again, and we'll look at a little bit of a presentation here. Okay. So one thing that scientists will do. You would do lots of this if you were doing science in school, or you can also do it at home as well, but you'll certainly practice this lots in secondary science when you go up to secondary school if you're not there already. And that is to draw your experimental setup, okay? Now this is really, really important, not to practice your drawing skills at all. It's really not about that. It's actually, you want to keep your drawing very, very simple, nice 2D, very, very clear for someone to look at. But this STEM skill here is really important for your recording. And that means you're taking down note of what it is you've done. And also it means that you or somebody else can come along, look at that, and you could repeat that. So science should always be repeatable. So this is a really, really good STEM skill to explore. Gives us time for our experiment to develop here, and also you to practice this really important skill. So what have we got here? Well, you saw my experimental setup. I wonder if you can remember that at all. What I want you to do is draw a really nice simple picture and see what you come up with. So I've started it off for you there. I've got my big beaker, and in that big beaker, I've got that line, just a simple line indicating where I filled it up to with water. I wonder if you could finish that. You do this in your head just now if you want. You can draw on a little bit of paper, you can scribble it down. Normally in science, it's a good idea to use rulers and straight lines, but if you're just doing a little scrap bit of paper just now, you can just give a little scribble. So perhaps I'll give you a little second or two to have a little go at what you would draw. How would you finish this off? Okay. So, I know I'm probably going faster than you can actually draw and think, but you can do this afterwards where there's a little bit more time if you like, and you can come back to this. So I would probably have drawn my little beaker suspended above there, okay? And in there you can see I've got my other mixture, and it's got lots of bubbles coming out of it as well. I've then got the plate over the top of that. So to draw the plate, I didn't have to be fancy at all. I've literally drawn a straight line right across the top of that just to show that I put a lid onto my experiment. Okay, I've got the little bit of black there outside to show that the small beaker was taped on. But if you came across this, you would have no idea what it was, would you? So as part of an experimental write-up, when you do an experiment in school or real scientists do experiment, what you would want to do there is add some labels. And these are basically just telling everybody and yourself, reminding yourself what everything is. Okay, so I could add all the labels onto these things there. Let's see if you could, before I show you the sort of the answers that I've put in anyway, let's see if you could label them. You could just, again, just do this in your head, or you can try writing it down. Okay. Let's have a little look then. So I'm going to bring up all the labels here. So there we go. We've got the large beaker. This actually is a 1 litre beaker. You could write that as well. It's 1,000 millilitres or a litre beaker. We've got a smaller one. I think it's 250 millilitres. So you could label that with the volume as well. That would really help somebody to really understand the equipment that you've used. I've got a plate. I've got a bit of sticky tape I've labelled just to show how it's sticking on, so it's not floating in midair by itself. And then importantly, of course, I've got the water and indicator. Well, it's bromothymol blue. You might have remembered. It'd be very impressive if you did. But water and indicator. And I've also got vinegar and bicarbonate soda into the other one there. So you've shown people what it is you've added to make this experiment happen. Okay. So this is really, really important STEM skill, as I said, for recording your results and for processing them and remembering what you did as well. And these are all, of course, linked to the creative side of your brain as well. Not because the picture itself is very creative, but because you're using your problem solving, you're using your memory, and you're linking things together, and you're making sense of stuff. And it'll help you in the future as well if you want to come back and do the experiment. But I actually think it's time to actually look at our experiment now as well. So I'm going to stop sharing my screen just now, and hopefully you can then see the experiment that we've got here. Okay, now I wonder if you can see anything a bit different. So remember, this was a lovely blue color before. Do you remember that? What has happened to it? It's definitely changed a bit, hasn't it? Especially if I swirl it around. I wonder. You see there? Well, this tells us that the chemistry of the ocean or the water, the chemistry of this water has changed in some way. And it can only be because of this carbon dioxide that we filled this part up with up here. Okay, so let me show you something else then that might help you with this. Okay, so we saw that it went a lovely yellow colour. It started off probably in the middle there, so around about what's called 7. This is a pH colour scale for bromothymol blue. So it started off blue sort of green, so it was probably slightly above neutral, which is something that isn't quite acid, isn't an alkaline, which is the opposite of an acid, okay? So it was in round about pH 7, perhaps a little bit above that, because it was in the blue end of the scale. But that carbon dioxide has turned it yellow, which I'm sure you can work out means that we have actually made it more acidic. So if in real life, we're putting extra carbon dioxide into the atmosphere that's causing global climate change, it's also having an effect on the ocean. And that effect is to make it more acidic. So it's called acidification of the ocean. So this is a pretty big problem, isn't it? And this is why scientists want to study this. But to be able to study it, they have to be very creative in coming up in ways that they can study it, and also understanding the results they get and understanding what influence that will have on all the life in the ocean as well. If you'd like to explore a little bit more about this, you can check out Dynamic Earth online, where we've got some resources. And on Dynamic Earth online, there's also lots of different experiments that you could try as well. Not all of them relating to the ocean, but if you try out some of these experiments, why not try drawing them afterwards? Why not have a little go at draw your experimental setup and keep practicing those skills? There's also been some other sessions from Glasgow Science Centre and Aberdeen Science Centre as well on this National Painting Forum from Scotland series of events. So why don't you check them out? And if they've got some really good experiments there as well, you could try drawing them up too. And these are really, really good skills for when you're doing your science in secondary school, and also just if you wanted to go on to do any sort of career and job that had an experimental aspect to it. Okay. So we explored a little bit of ocean science there, not going into a huge amount of depth. As I say, you can look at Dynamic Earth online on our website to find out more. But the last thing I want to do is I want to take you from the ocean and take you onto the land. And I want to explore a little bit of Edinburgh geology. Now, Dynamic Earth here, let me show you this picture here of Dynamic Earth. Now, Dynamic Earth is backed up by this huge big rock face. If you've ever had a chance to explore this, you might know it's called the Salisbury Crags. And beyond the Salisbury Crags is this big open area. It's called Holyrood Park. And it's actually a site of special scientific interest because of the really important animal and plant life that's there, and also the geology as well. And that's what I want to explore a little bit with you today. The geology, that's the rocks and the processes that made the earth around us. So that peak over at the right hand side of that picture, that tallest part there, is called Arthur's Seat. Some of you might have climbed it before. Now Arthur's Seat is an extinct volcano. That means it doesn't erupt anymore and there's no risk of it erupting at all. Okay, it's not going to erupt anytime soon, any ever again. The last time that erupted was around about 350 million years ago. So that's a long, long time, isn't it? 350 million years ago. And in that 350 million years, the world and Scotland has changed a huge amount, including, of course, the climate as well. It's changed naturally, very different from man-made climate change, but it's natural climate change over a long period of time. But we can actually find evidence for that very different environment and different climate in Holyrood Park, right behind Dynamic Earth. Now, when we're back open again, hopefully from the autumn, we can actually out, and it's the kind of thing we do with schools, and it's the kind of thing we do with family groups as well, is we take walks out into Holyrood Park to explore the amazing geology that is out there. Luckily, I can do that with you today through photography. So thank goodness for technology and such. I'm going to take you to a little area here called Camstone Quarry. But first of all, before we go there, we should think about some of the evidence that we're going to be looking for. Okay. So outside Dynamic Earth, you'll be able to see some of these maps attached to rocks. Now this one here, this map here, outside Dynamic Earth, shows us what the world, our best understanding of what the globe and what the world map would have looked like 350 million years ago. Unrecognizable, isn't it? It's nothing like the world map that we have now. And that's because the continents have moved around over the surface of the earth there. Now, that little red dot shows us where Scotland would have been 350-ish million years ago. That little red dot was where the land that we now call Scotland, it was there. Where is that? It's not up in the cold, towards the cold north like we are now. It's down in the middle of the planet. Have a little think, what do we call that? We call it a band that goes around the center of the Earth. It's like a make-believe sort of line. It's called the equator, isn't it? Okay. Now, at the equator, what are the conditions like? Do we have any idea? Okay, quite warm, aren't they? It's pretty hot at the equator, and it would have been back then as well. But also that red dot shows us, if we look at the key up at the top, it's in that light blue area, or on the edge of that light blue area. And that means that it was shallow seas. So the evidence that we're going to go and look for in Holyrood Park is evidence that Scotland, the land that we now call Scotland, was in shallow, warm seas, tropical seas. So can you believe that up in Holyrood Park, where it's now high ground, raised, it's mountain, hilly, not mountainous, but hilly, we can actually find evidence of warm, shallow seas from hundreds of millions of years ago. Well, let's take a look. As I said, we're going to take you to a place called Camstone Quarry, okay? Now, Camstone Quarry looks a little bit like this. It is, of course, a quarry. Now, quarries are where rocks have been removed for building, and this quarry was used, there's evidence it was used as far back as the 1500s, but most of it would have been used in the 17 and 1800s to remove rocks and to remove sandstone in particular for the building of the new town in Edinburgh. But in the quarrying, the blasting apart of these rocks and such, have discovered lots and lots of geological evidence that has been preserved and it's been left for us to now view. So remember, the geological evidence we're looking for is that of warm tropical seas that Scotland used to be situated in at the equator. Okay, so what sort of thing might we be looking for? It's pretty tricky, isn't it? So I'm going to show you a few things that we take visitors to see and see if you can work out what they might be. So first of all, one of these rocks there that's lying on the ground looks a little bit like this. That's a really strange pattern for a rock, isn't it? The ruler at the side there is just a normal 30-centimeter ruler, just to show you the size of what we're talking about. It's not absolutely massive, but the rock's bigger than a ruler. But all these little lines along there, what on earth could they be showing us? Well, I don't necessarily expect you to know offhand without any clues and things. So what I want to do is show you this little picture here and see if it helps you out at all. Do these lines there look similar to this little picture I brought over the top? I bet you can see the same patterns there. And that's because this rock up in Holyrood Park in Camstone Quarry is actually a preserved sort of dried muddy puddle. That's like dried mud cracks from hundreds of millions of years ago. Now, what this tells us is that this area used to get wet and then get very, very dry. Okay, so wet and dry, just like you would get at a sort of tidal zone, a flat tidal zone right beside a water, beside a shallow sea, perhaps. You'll see that land where it gets wet with the tide coming in, then when the water goes out, if it's hot enough, like at the equator, that's going to crack and dry. And that's actually what we're left with there. We've got that preserved muddy cracks there. But that's not necessarily enough evidence on its own, is it, of warm tropical seas. So let's keep looking. Here's another rock that you find up in Holyrood Park. I wonder what you think this might look like. Again, I'm going to give you a little clue. Do you see any similarities there? See how those ridges on that rock sort of bump up and down, just like the sand in that picture that I brought up on top there. So there, we've got more evidence of a tidal zone where the shallow sea's coming in and then coming back out. Now, if you go down to the beach, if you got a chance to explore the beach this summer, get a chance to go, you will be able to see these ripples and but anywhere there's a tidal area. So here we found more evidence, preserved ripples in the rocks there. We can see more evidence of that shallow sea. Perhaps in that picture I brought up there, you've got the forested area up in the top left. So perhaps that's where the kind of place that muddy cracks would be found as well, in that tidal zone that the water might be coming in and out of and then drying under the hot tropical sun. Okay, so that's two pieces of evidence. Is there any more? Well, I'm going to show you some other rocks here, and I want you to observe these rocks, and you're using your creative observation skills here, your imagination, you're using your problem solving, your open-mindedness as well, and your curiosity to take you back 350 million years ago and think about what these rocks might be showing us here. Can you see anything in those rocks? Let's get another one here. I bet you can spot all those lines going across there. Can you spot all those lines? Those are layers. And this is layer upon layer upon layer of sand getting built up over tens and hundreds of thousands of years, if not millions of years, all getting layered up there and compressed underneath the water. And this is actually sandstone, and this is a sedimentary rock. So it's sedimentary means like sediment, like bits of sand land down in the bottom of the seabed, get compressed down, and they squeeze, squeeze, squeeze over millions of years until they turn into hard sandstone rock. Okay, so this is more evidence of that tropical sea environment. So we've got the ripple rocks, the dried muddy cracks, and now we've got sandstone layered up as well. So sandstone, of course, you get sand in the desert, but sand in the desert doesn't get compressed like this, like it would underneath a sea. So here we've got more evidence of that it's a marine sea environment there. So are you convinced? You convinced that all these millions of years ago, Scotland, when Arthur's Seat was an erupting volcano, Scotland was in a warm tropical environment? Well, don't have to take my word for it necessarily, because we've got a little bit, and a last little piece of the clue that we can work out how long ago all these rocks actually come from. But before we do that, yeah, there's a little picture there, so you can see all the layers there actually. So let's have a little think about how we can work out how old those rocks are, right? So this section I'm showing you here is probably about, if I look here quickly, this is probably about 6 meters tall, this little section I'm showing you here, just roughly about 6 meters tall. So those 6 meters there, okay, that's made up of little increments of layers. And let's say, very roughly, for the sake of this, very, very roughly, I think it takes about 10,000 years for a centimeter of that sandstone to build up. Okay, so we can work out then how long it takes for this whole section to have been built up. Okay, so let's look. 1 centimeter takes about 10,000 years. So we've got 6 meters here. So how long does that take? Well, 6 meters, how many centimeters is that? You might know. Have a little think. 6 meters is 600 centimeters. Okay, so 600 centimeters. So what we've done there is we've got 600 centimeters on the left-hand side here. So that means we've times the 1 centimeter that we started with by 600, sorry. So we've now got, so we've times the left by 600. What we need to do there then is times the right by 600 as well. So 10,000 years times by 600. What's that going to give us? Can you work that out? You need a little second. This means then that this little section, this isn't even all of it. This is just a little section of this sandstone here. This is showing us that this little section here is 6 million years old. Now this, of course, is what's been pushed up to the top as the Earth has moved around, the continents have moved, and the Earth has been lifted up above sea level, and now it's up in Holyrood Park, high up. This has all been pushed up, but there's loads underneath the ground that we can't see. So if this little section alone is 6 million years old, can you believe me that the land all around Holyrood Park could be as old as 350 million years? If well, it's older than that, some of the rocks will be older, excuse me. So this is just another piece of that puzzle there. So we're adding all these bits up. We've used our maths and numeracy, which is a big part of STEM skills. We've used our observation to look at these different rocks there, and our imaginations to sort of think what they might mean and to understand the geological science that we're being shown here. But there's one last STEM skill I want to finish with for just now. And that is a little bit similar to when we did our experiment looking at the ocean. And that is to record what it is we've got here. That's to look at our observations and to record them, to write them down, and it means that you could come back to that. It also means that somebody else could look at your recordings and they could actually know what it is you're looking at and where you got your evidence. So for that, what I'm going to do, take you back here a little bit, we're going to look at field sketching. I'll give you a little bit of a preview there by skipping through the slides. So field sketching is a little bit like how we draw our experimental setup for the chemistry experiment we did there, but this is more something you would do in geography or in geology, which definitely fall under STEM, science, technology, engineering, and maths. So with a field sketch, you might take an area of Camstone Quarry or any other area where there's rocks and stones and things you want to observe, and you might draw a picture of it. Now, I've already got a photo of it here, so why wouldn't I just keep that photograph? Well, by drawing this, you're really having to use some of those creative STEM skills. You're having to think really clearly about this. You're having to make connections in your brain as you observe it with your eyes, but then try and get it down on the paper. And these are all creative things. These are all part of the picture that will help you remember what it is you're looking at and also to understand it. So a really big part of any STEM subject is really understanding what you're looking at. And that's a very creative thing to be able to do. So any scientist has to go through this process. So why don't you have a little go at having a little scribble down of this area? You can watch this back on YouTube and you can have a little look at some of these pictures that I've shown you. Perhaps that's some of these rocks here. Perhaps that's some of the ripple rocks and the dried muddy puddle. You can have a little look through them and have a little sketch of them and see if you get any more from this. You get any more understanding? Do you get any more appreciation of what it is you're looking at, the evidence you're looking at? This isn't about drawing a beautiful picture that it would win awards for its artwork. It's not about that. It's similar to when you drew your experimental setup. You kept things nice and simple. So all you really want to do is, first of all, draw the outline of what it is you're looking at, and then you can start adding in details. I'll show you my picture, and I think we'll all agree this is not a beautiful piece of artwork. But, oops, it's not popping up there. There we go. So you can see it's not a beautiful piece of artwork, but anybody looking at this that went to Camstone Quarry will be able to work out the angle that I was standing at and what I was observing. So if I then added labels to that as well to say there's something really interesting here. There's a rock here that looks like a dried muddy puddle. Here's some layers. All these different little bits there I can add onto my drawing. Somebody else could come along and understand when they're in the scene, they can understand what it was I was looking at the time. Okay, so I would really encourage you to get outside for a walk, see something interesting. Perhaps you want to draw your local area. Perhaps you want to draw some of the rocks that you might find in your local area. You might even want to just try drawing your houses, or perhaps, or if you go further afield up into hill, you might want to draw the landscape that you see there. Start maybe on a small little area and you can look bigger. And I bet the more and more you do this, the better you will get at it, and the easier it will come to you. Now that's why we started with the squiggle drawing back at the start, not only to explore what creativity is, but because by doing more things like those squiggle drawings, now you could start with any squiggle you wanted. What you're doing is you're opening your brain up, you're making connections there that allow you to go through these creativity STEM processes. The same as when you used to draw a field sketch. The more you do it, the better you'll get at it. The more you draw an experimental setup, such as our one that we did here with our ocean, the more you do it, the better you'll get at it, okay? And the more easily it'll come to you, which are really, really important STEM skills. So I hope you have enjoyed some of what we looked at today. So today we have explored creativity and its link with STEM, looking at open-mindedness, problem solving, looking at the imagination that's involved in that. And also, we've looked at some other STEM skills. We've looked at our observation STEM skills. So that's watching an experiment and working out what's happened from it and getting an idea of what has gone on. You've also observed a geological scene and made observations from that and worked out what's happened, okay? So you might have also learned something along the way. So those are the three things. So I hope we met some of our objectives, if not all of our objectives today. And what's left today, with the bit of time we've got, is I can answer any questions that you might have. So if you haven't already typed a question into the chat box down at the box there, you can have a little think about any questions you want to ask me about the session that I've just run today. But it could also be about anything that you think Dynamic Earth might know about. So that's anything to do with planet Earth, about the environment, about climate change, anything really about science, technology, engineering and maths. We might be able to help you out. Perhaps there's something in school that you did before the school's finished in March. There might be something, maybe some of the homework that you were doing that you were sent home from your teachers during lockdown, perhaps that you weren't very sure about. So why don't you type your questions in there and I can try and answer them for you. So there's a little question here. Do you have any resources online to learn more? Yes, absolutely. So you can head over to our website, that's dynamicearth.co.uk, and underneath the Learning tab, you'll find something called Dynamic Earth Online. You can also just type Dynamic Earth online online, Dynamic Earth Online. If you type that in, it should come up with the page. And there, we've been putting all through lockdown, we've been putting resources up every single day, Monday to Friday. We've been putting new content for you on there. We also, during the summer period when schools were officially not working, we've been doing our Dynamic Earth staycation. That's been us exploring the globe, looking at planet Earth from the comfort of our homes in Scotland, because it's not very, like, we're not going very far, are we, just now? So we've been doing our Dynamic Earth staycation, exploring the polar regions, the African savannas, exploring freshwater river environments, and the rainforests, if that's all of them. So you can explore these areas. So there's lots of stuff that you can have a little look at online there as well. I'd also encourage you to check out our friends at the other science centres as well. They've got loads and loads of resources. If you haven't been following people like Glasgow, Dundee and Aberdeen, they've got some great stuff for you to check out too. Okay. Anything else? Any other questions coming in there? If you do come up with any, if anyone does come up with any other questions they want to ask, what you can do is send us something on Facebook, Instagram, or Twitter. You'll be able to find us on there. So you type in Dynamic Earth into any of those platforms, we should pop up, and you can get in touch with us through those measures, either through private messaging or just on our walls, and we'll be happy to get back to you. That'll also give us ideas as the kind of things you'd like us to explore in the future. Do check out our social media, because every single day we're posting brand new stuff for you to look at, which are videos, activities, sharing other people's resources. So it's worth having a little look there. That's great. Thanks for it. Some people saying on the chat there, not everyone able to see this, but just some people saying great that we've been doing this during lockdown and helpful for keeping young children engaged and learning new things. So yeah, absolutely, it's our absolute pleasure to be able to do that for everybody. And yeah, if there's anything in particular you'd like to find out more about, do get in touch with us through our website and our inquiry form, or through social medias. I'm going to give just a little bit more time for some questions, and if none come in, then we will just end it there. I think that might be it for today then. Oh, there's a question coming. So where is the best place to learn about turtles? Oh, that's nice. Okay. So there are some, I wonder if there's some resources on the WWF will probably have very, very good resources about sea turtles and such. They're actually one of my favorite animals, but that's something we need to do on Dynamic Earth a little bit. So I absolutely love sea turtles. So perhaps you could look on WWF's website, will probably have something. I wonder if there's anything else comes to mind. So if you go to www.noaa.gov, so that's the National National Oceanic and Atmospheric Administration, you should find stuff about sea turtles in there. Sorry for stumbling over my words there. Okay, well, I want to say a massive big thank you to everyone that's come to join us today for the live session, and anyone that's joined us afterwards from YouTube. Thank you so much for coming along to find out what Dynamic Earth does and what we've been doing during lockdown, and how we can help you and your young learners, whether they're still at home or going back to school. Yeah, I hope this is giving you a little bit of an insight of what we offer here at Dynamic Earth and how we can help. So do please get in touch with any more questions. I'm going to stop the recording now, and I'll hopefully see you all again in the future at another session. So thank you very much. Bye now.